Greetings AP Stat. This is the third and last part of Chapter 22. We're just doing some odds and ends here. A couple of things that we haven't talked about yet that will be helpful for you in your homework and for future packets of AP level problems. So, computing T-star values for confidence intervals for the mean is where we will begin. So we would use inverse T if you have some flavor of TI-84, and there are several ways of doing that depending on the capabilities of your graphing calculator. For a TI-83, however, the process is a bit more complicated. And we'll go through the process for a TI-83. I'll show you that on my digital TI-84. Okay, so here's what we're going to do. We're going to find a T-star value for a 90% confidence interval, and we're going to let our sample size be 15, which means in this instance we would have 14 degrees of freedom, right? And then we're going to find a 95% confidence interval's T-star value, where the sample size equals 10. So in this case, there would be 9 degrees of freedom, okay? So let's get an idea of what our process is going to look like. Here is a bell curve, all right? Thanks to the University of Iowa's site, I've used them before to generate bell curves with areas and such. So thanks, shout out to the University of Iowa for an awesome little applet that they've created. So for number one, I have a 90% confidence interval. So let's say between these two posts right here, these two cutoffs, you have 90% of the area in between. That means 10% is split on either tail, okay? So now what I want to do is say, okay, if I am using inverse T, that starts at the far left down here, and we chomp, chomp, chomp area until we are done, okay? So if I have 90% confidence, that's 90% in the middle, and I have my remaining 10% split between the two sides, that means I'm gonna have 5% over here, 90% in the middle, and 5% over there. So if I'm starting from the far left, which is what inverse T does, I'm going to chomp, chomp, chomp this first 5% and then the 90%, and that would leave 5% left over. That will find this cutoff. Now, we want this cutoff specifically because that will give us the positive value, all right? And that'll give us the precise value for T star. This will give us the equivalent except negative. Let's get the positive one here. Now for 95% confidence, we have 95% in the middle and the remaining 5% split between the two tails, all right? So that means we have 2.5%, half of 5% over here, and we have 95% in the middle. That means we have 0.975 to get to this post right here, to get to this cutoff. That would leave 0.025 over here, all right? So we will now go to the calculator, and first we're going to find a T-star value for 90% confidence, n is equal to 15, and then we'll find 95% confidence, n equals 10. Then I'll show you the other method over here for older calculators. If you have an older calculator, we'll do both T-star values there as well. And if you don't have an old calculator, you can feel free to skip right on to the next section of the video. Okay, it's calculator time. Let's go to second distribution, and we're going to go to inverse T. And it's going to give us some options here. We have area, and that area is going to be for our first problem. Remember, 90% confidence, and we determined using our little bell curve model, it would be 0.95, all right? That's the amount of area we need to chomp starting at the left. And degrees of freedom, since our sample size is 15, for these problems, we have, for this section, for chapter 22, our degrees of freedom would be 1 less, so it's going to be 14 degrees of freedom. And then we click paste, and there we have it, about 1.76. Great. Now let's find our other t-star value. I'm going to go to second distribution again. We're going to go to number 4, inverse t. And now I'm going to change it to 0.975. Remember, this is 95% confidence. Alpha would be 0.05. We split that in half on each tail, so we have 2.5% plus the 95% in the middle that we'll need to chomp to get to our upper extremity, all right, our upper cutoff. And so we have our degrees of freedom is 9. That's sample size is 10, so for chapter 22 problems, our degrees of freedom would be 1 less. We click paste, and bada bing, bada boom. There you have it, 2.26 approximately. Now, for older calculators, this is what you will need to do. For your TI-83s, you're going to need to go to Stat, and you're going to go over to Tests, and then you scroll down to T interval. Okay, you're going to hit Enter, and we'll do problem number 1 again. So this is a 90% confidence interval, sample size of 15. We would click Stats, and then we would center our t-distribution curve at 0, all right? And then for the standard deviation, we would type in the square root of our sample size. And why do we do that? Well, I will leave that to you to investigate. And we would say n is equal to 15. Very good. And our confidence level is 90%. These would give us the cutoffs for a confidence interval at 90% confidence, sample size of 15, using the T model. We hit calculate. And then there is our upper Z star value. All right, and then there's our lower value, which is the same. It's rounded a little differently. They round to 4 places up here and 3 places because of the negative sign taking up some space. But this would be what you would use, about 1.76, just like last time. And just so you can see another example, let's do problem number 2. We're going to go to tests again. We'll go to T interval, that's number 8. And then we would say center at 0. Our second sample size is 10. That's our 95% confidence interval. And sample size of 10. So we'd say square root of 10 for our standard deviation. Sample size is 10. And we would say 0.95. Okay. Now we're going to hit calculate. Should get the same answer as before, and we do. We get about 2.26 approximately. Now here's one more problem type for this section. This is finding a large enough sample size to form a confidence interval for the mean of the population. So given a certain amount of error we would tolerate, as well as a certain level of confidence, we can find a sample size appropriate for computing a confidence interval for the mean. So given a certain level of confidence and a certain amount of error, how wide our interval is on either side of wherever our interval is centered, on either side of the sample mean, we can find a sample size to get us a confidence interval that fits both desirable characteristics, high confidence and small error. And this is the formula that will do it. This is a rearrangement of the formula for margin of error for a confidence interval for the population mean. It's a bit of just algebraic, moving things around, a little algebraic dance, if you will. Okay? We are going to find a Z star using inverse norm, unless you remember some critical values for Z, unless you remember some Z star critical values. I bet you've memorized a few of them at this point. And then we would substitute and solve for n. So we'll have to find a margin of error, a Z star value that's based on your level of confidence, and your standard deviation, ideally for the population. Though if all we have is a sample standard deviation, sometimes that's all we have to work with. The textbook that you're using requires a more complicated method for this type of problem, And having taught AP Stat for a little while, I can assure you that the answers they are looking for are based off the formula that you are seeing. The formula for margin of error solved for n for a normal model. Even though there is a more accurate way of doing this, this is the formula you're going to be using. Do not use the textbook's method. It is more accurate. It is a better method, but you can just stick with this one because the answers to multiple choice questions are going to be based off of this formula. All right, so a company claims its program will allow your computer to download movies quickly. All right. Horton Hears a Who was made into a movie, but that's not why we see Horton Hears a Who. If you've been watching my videos on AP Stat for a while, you may be familiar with why we need to reference Horton Hears a Who. All right, so we'll test the free evaluation copy by downloading a movie several times, hoping to estimate the mean download time with a margin of error of only 8 minutes. Boy, do we have some time on our hands. We think the standard deviation of download times is about 10 minutes. Do the writers of our textbook understand that they're speaking to AP Stat students who have to watch these videos for this crazy teacher? Anyway, so how many trial downloads must we run if we want 95% confidence in our estimate with a margin of error of only 8 minutes? So we have some substituting to do. If we want 95% confidence, that z-star value is going to be 1.96 approximately. That's probably one that you memorized. We would say margin of error of only 8 minutes. So that means an 8 would go here, 1.96 would go here, and we think, I guess we're going with our thoughts here, the standard deviation of download times is about 10 minutes. All right, very good. We got 10 minutes here. I've really been dunking on the textbook a couple times this section. I really should be careful about that. This is an extremely well-written textbook that we're using. I just think that some of the examples are a little funny. And that is by design. They like to employ humor in this textbook, which I appreciate. All right, moving on. So we do our substitution, and we square that, and we get 6.0025. Now, here is where Horton Hears a Who comes in. Because if I were to round this as I conventionally would, 5 and above, give it a shove, 4 and below, let it go, I would round down to 6, but that's not going to cut it. This is the minimum sample size, according to this formula. This is the minimum sample size that I would need if I want this much confidence and that much of a margin of error. If I go below this, I am sacrificing the quality of my confidence interval. I need to round up. Even though my decimal is basically 0 after that 6, I need to round up. I should not sacrifice quality. So I'm going to round up. I'm going to sample an additional time. We'd say n equals 7. Our answer is between 6 and 7. We must round up. A download's a download, a trial's a trial, a person's a person, no matter how small, all right? Even this small demands that we round up. A person's a person, no matter how small, just like we learned in Horton Hears a Who, all right? So we would say n equals 7, and that is your final answer. This is, of course, not a final answer because you can't download something completely 0.0025 times. We need to round up to 7. All right, one more additional topic here. We are back with interpreting computer output. So not just your calculator you'll be looking at, you'll have to reference computer output. Not too much going on here. We are testing a hypothesis. Here is the null hypothesis versus the alternative hypothesis. We're testing for the mean here. We're including labels. This is apparently a study about sleep, probably the one done on that college campus. Here we have the sample mean, ho-hum. Here is our t-test statistic, and degrees of freedom are given, and here is a p-value. And the p-value is usually given last in computer output. This is a very easy bit. of computer output to read. It definitely gets more difficult than this, but I just wanted to let you know what computer output would look like if you were using something other than a graphing calculator, which you will be expected to know how to interpret on the AP test, I assure you. And here's your homework, which you will be expected to do as well. Have a great day.